Welcome. I'm Vihan from Scientific Presentations and Explanations, and today we're going to discuss biomedical engineering. We are going to discuss the many parts of biomedical engineering, like what is it, the different subsets or the different parts of the science field, and the universities and courses people should take to learn biomedical engineering. And finally, at the last, we are going to find out how much someone in biomedical engineering would earn. Biomedical engineering is a very progressing field of science and it has many parts in it. For example, one of the ideas made by university are nanotechnology, and they're developing such robots to correct mistakes in DNA and prevent cancers along with any other radioactive or somewhat DNA related diseases, and can be used for making prosthetic arms and legs which will replace the arms and legs of people who have lost them during accident. We also can enhance the genetic engineering tools which will help us understand our own genome and how we function. Now we are going to go through the subsets and the different parts of biomedical engineering. They are 1. Bioelectric engineering. Now this subset mainly consists of the programming and electrical part. Now you might be thinking, where does this come? But taking the example of a prosthetic arm, the way the code works, because when a prosthetic arm moves, it always needs to read the neural signals, and the circuitry to make that is just what bioelectric engineering consists of. It also somewhat consists of the computer science, as in the different types of codes for any other advanced projects and many other things. And so bioelectric engineering is extremely important here. Now we are going to move on to the second subset, biomaterials. Now biomaterials is mostly made up of chemicals, physics and biology. It doesn't consist much computer generation, because biomaterials is the study of the types of materials used in the body. See, when a foreign substance enters the body, the immune system attacks it. Therefore, in many certain equipment that has to be put into a person's body, like a pacifier, the immune system keeps on attacking it and soon enough breaks it down. And this is very problematic and dangerous because that can cause the failure of the equipment. Therefore, biomaterials will include the study of such various substances that make sure or prevent or coax the immune system and our body into not degrading it over time. There are certain methods for this. For example, coating them with a certain liquid to make it look like it is harmless, or taking painkillers or immune system controllers which will suppress the immune system in that particular region of the body. And now we are going to move on to computational biology. This subset is fairly easy to understand. It basically consists of very important research analysis data and data analysis. This means that it consists of the way researchers analyze data, and that is very important, as if the data isn't properly separated, then it could be extremely difficult to understand. Now we move on to nanotechnology. Now this one might be very familiar to you, as in many movies they show nano robots or some weird kind of creatures in the human body or cyborgs or something, but that's actually true only on a downsized scale. Nanotechnology is kind of like computer science. You know how you made prosthetics and arms only at the cellular level. So many extremely far-fetched ideas, there are many ideas, and this field of science is one of the newest and one of the only of its kind, and it's in lot of development right now. Several ideas about its future are that somehow it could protect us from radiation and mutation diseases caused by it, for example cancer, with teeny tiny robots programmed to swim in our blood and fight diseases too. Now this has a very few chances of happening, or at least it will take an extremely long time, as many experts say that to downsize the motherboard circuits at such a small scale is going to be extremely difficult. However, many economically groundbreaking discoveries and ideas have been developed in this field. Now we move on to observing the academical and learning part of the biomedical engineering, as in what it takes to score proper degrees and a job here. Now, in order to secure a job in this field of medical science, an undergraduate degree of at least one of the below subjects is required. For example, biomedical science of engineering, electrical engineering for electrical computer science, and mechanical engineering. Now, I am going to explain how these degrees relate to biology. Biomedical as in how it consists of the biology part, and this will include nanotechnology, growing tissue and cellular engineering, and biomaterials. Next we have electrical engineering, which will basically stand for the computer and programming, especially very importantly the circuitry and coding in prosthetic arms and in nanotechnology as well. And mechanical engineering will be simply just using the physics and the mechanical joints, as in how the prosthetic arm will move once it's got the power and the joints have to be made. To break it down, this field requires strong levels of all of the following: maths, chemistry, physics, computer programming, and molecular biology. Now these are basically the core subjects that you need to study, and these are very important. If you aren't good at these things, then it is very unlikely that you'll get a job in biomedical engineering. To learn biomedical engineering, there are many colleges, and many people don't know which ones to look for. For example, I know that many people just start thinking that Harvard, Oxford, and Stanford universities are very good and therefore they should go for them. But in reality, those colleges are famous just for their general knowledge, as in they are good at covering every single topic. But if you want to just learn biomedical engineering, that's what you want to major in, then some very good universities to learn biomedical engineering are Johns Hopkins University, Massachusetts Institute of Technology, the Duke University, Emory University and the Georgia Institute of Technology, Stanford University, University of California, Berkeley, University of California, San Diego, and the University of Pennsylvania. Now, if you live in India, then top 10 colleges or universities to learn biomedical engineering are All India Institute of Medical Sciences, Indian Institute of Technology, Delhi, Indian Institute of Technology, Maharashtra, Manipal Institute of Technology, Karnataka, Netaji Subhas Engineering College, West Bengal, Indian Institute of Technology, Uttarakhand, SRM University, Tamil Nadu, Vellore University of Technology, again in Tamil Nadu, Indian University of Technology in Uttar Pradesh, Central University of Karnataka. Overall, biomedical engineering has good career opportunities is very interesting and advanced field of science. It also has bright prospects on enhancing the quality of human life. So friends, goodbye for the day, and I will meet you next time with a new interesting topic.